So at this point, we've talked about factory methods, and some of the factory methods for creating streams would be the stream method. We saw how the stream method ends up using the stream support.stream factory method. That uses a splitterator. I've talked about splitterators. I've shown you how you can make a splitterator. So that's kind of how things get kicked off. Then they flow through the various intermediate operations, and they end up in a terminal operation. If they end up in a terminal operation that's the collect terminal operation, then collect will end up using a collector in order to take all the elements in the stream and consolidate them into a final single result, which is typically a collection. And so what we're going to do now is we're going to talk about collectors. And collectors are sort of the other end of the spectrum. So if a splitterator is used to split things and then intermediate operations process it, then collectors are used to pull everything back together again. And we'll start out by talking about non-concurrent collectors for sequential streams. Later, we'll come back when we talk about parallel streams, and we'll talk about the use of non-concurrent collectors for parallel streams, which sounds like an oxymoron, but it's not. And then we'll also talk about concurrent collectors for parallel streams. But that'll come later. So first, let's just kind of recap where this occurs. I think this is review at this point. So as you can see, when you have a stream that has a collect terminal operation, it uses a collector in order to take the elements from the stream and put them someplace, like into a collection. So in this particular example, as you saw, what you get out of the box with the toList factory method that comes from the collectors utility class, that's a way of being able to collect all the elements here, which would be, in this particular case, the sorted names of Hamlet characters starting with H that have been consistently capitalized. It'll put them into an array list. So that, of course, raises the question, what is a collector? Well, a collector is an interface, and implementations of this interface, either ones that come out of the box from Java or ones that you build yourself, as you will do in assignment 2B, are basically objects that are capable of accumulating input elements from a stream into a so-called immutable result container. And the key focus there is mutable, which just means it can be changed. That's in contrast to reduce, which does not use mutable objects. It uses immutable objects. There's a couple of different types of collectors. You can either have concurrent collectors or non-concurrent collectors. And there's a couple other variants we'll talk about as well. But the key top-level discussion is whether it's concurrent or non-concurrent. And the way that you control this is by something called characteristics. And characteristics are just a set that indicate whether something's concurrent or non-concurrent, whether they're ordered or unordered, and whether they have something called identity finish semantics or not. And I'll talk more about that in a second. The distinction between concurrent and non-concurrent collectors is only relevant for parallel streams. So as we'll see when we talk about parallel streams a little bit later, if you have a parallel stream, then the choice between concurrent and non-concurrent collectors actually is meaningful. Our discussion here is only focusing on sequential streams. So it only makes sense to talk about non-concurrent collectors. It makes no sense whatsoever to talk about concurrent collectors for non-parallel streams because there's nothing parallel that's going on there. So we'll cover the concurrent and non-concurrent collectors for parallel streams in a little bit. So you can think of a non-concurrent collector as a way just to accumulate elements into this mutable result container. So it's like a piggy bank. You're dropping your elements into there. And essentially, as you may have surmised before, a collector is the inverse of a splitterator. So if a splitterator is responsible for taking the input and breaking it up into chunks, which we just talked about, then the collector is used to take those chunks and reassemble them. And there's a bunch of cool, interesting elements of how all that stuff works. So that's a very quick overview of non-concurrent collectors.